Hello, test, test. Can someone tell me in chat if they can hear me? Test, test. We'll be starting in just a moment. Just a moment. Just leaving some time to let some people see the stream, get in here before we get started. Awesome, awesome. Get the camera on here. Yeah, so I found out for some reason with OBS, if you hide the camera input, it won't work when you turn it back on for some reason. But if I just slide it over to the right out of frame, works just fine, you know. Technology. I'm truly a masterclass of a streamer, you know. Really got the high-end specs here. How's everybody doing? The six of you here, how are you doing? Everything going all right? Stressful day? It's Friday. At this time of day for Friday, probably most of you are done with work or whatever. I don't know what time zone you'd be in, but it's Friday. Feels good. Feels good. We're going to be finishing the second half of the problems we started in the last stream. So that'll be the last 11. And yeah, I'm looking forward to it. These problems are pretty cool. Yeah, I think this little graph it's giving me for viewers is not up to date at all. I've got like 4 different numbers for viewership right now. So I don't even know how many people are there. Let's get a show of hands in chat or whatever. If you exist, type in chat. I'm going to get started in just a couple minutes. Yeah, I have a bit of a cold, so if my voice starts to fail on me, I've got like a gallon of water behind me. I might need to start chugging water to get through it, but I don't think this will take us more than an hour or so. So the last stream had some doozies, but I think these 11 problems on this part are not quite as bad. Alrighty, well, I don't know if the viewership's going to go up. It looks like it's going to be a low viewership stream today, but that's all right. It's for posterity, and it's for me studying for the GRE, so, you know, hopefully you guys trickle in as you come. If you're not able to stay, you know, leave a like, subscribe if you haven't already. I'll get started, and maybe give it another minute. 1 more minute. Hopefully people show up and start doing math. I think I got the window capture to work, so we'll see. We'll see if that works. Let's give it a try while we're sitting here, right? Yeah, we had some technical difficulties last time, but I think I worked at least a solution out for all of them. So let's see. If I do this, yes, yes. Now my face is in the way, but it's here. It's here. It's on the screen. You can move me around. Yeah. So we're doing this. We're following this University of Chicago GRE Prep. They've got 6 weeks, and we're doing week 1 right now. We're just finishing it up. This is our first week of study, and this is the first week of problems. But yeah, it looks like the window capture is working well. You guys can tell me how it looks on your end, and I should be able to just, there we go back to the iPad. It's fancy. Living large. We got nobody in chat. It's all right. It's all right. Thank you for those of you who are here. All right, I think my minute is up, so let's get started. Alrighty. Guess I should have left the window capture up because we need to look at the problem first. So let's see. Let's bring that up. Alrighty, so this is going to be our first problem right here. So let me get a new page open on the iPad. Yeah, so we have phi of x and psi of y are 2 smooth functions defined on R. We're going to let S be a positively oriented circle of radius 1 around the origin, and we want to know which of the following is going to be 0. In this case, like identically 0, so it's always going to be 0. You know, because you could like plug in some values and make that stuff 0. But we want to find out what is always 0. So we have those 3 integrals right there. And so let me get to the iPad and we can get started on it. Alrighty. Alrighty. So let's see here. Get my notes ready. See, this is in part a study stream, in part a preparation stream, kind of to demonstrate that I am in fact studying. So I have prepared some of these problems. Some of them I haven't done all the way through. But for the most part, I want to, not be stuck on a problem especially for the first few streams. Hi, Abraham. You were here last time, weren't you? Good to have you. But anyway, yeah, some of these I have prepared some of them just to make sure I know what I'm talking about. And then as we progress kind of through the study curriculum, I'm going to be moving more towards just kind of like unprepared problems. So that's kind of what we're working with here. But anyway, so let's try, and we're going to be using Green's theorem for this. Let me move my face cam somewhere that's not going to be in the way. I guess this is probably the best, but I'll try to like be cognizant of my face so I don't block the math. Yeah, no problem at all. No, it's part of a live stream. You're not interrupting. We're just hanging out. I think hanging out before the stream is ideal, right? Talk a little bit, chill before we get down to business. But anyway, let me get this up here. So our first integral is integral over this surface S, which is a positively oriented circle of radius 1 around the origin. That's a terrible integral symbol. Let me change that. Integral of S, and then we've got phi of y dx plus psi of x dy. So we are going to solve this using Green's theorem. So let me write that out for you. Can you guys hear me okay? I kind of put the mic on this side, so if I'm like leaning too far out, I can move it. Let me just test that real quick. Can you get over here? Good, decent audio? Maybe? Perhaps? Yeah. Hopefully it's all right. Anyway, we're going to recall Green's theorem, which, here, I should write the name. Green's. Where we've got, you can write Green's theorem a bunch of different ways, but we're going to use the one that like is very applicable to this problem, or this integral, I guess. We have p dx plus q dy. That is equal to the double integral over d of partial of q with respect to x minus partial of p with respect to y, and then that's going to be dx dy of like the whole thing here, like that. Yeah. Okay, so in this case, our p and q is going to be kind of our coefficient. See, my face is already in the way. Is going to be the coefficient of, how about I go over here? We'll find a place. We'll find a place. Will I take mental note of it? Who knows? But we will find a place for the face cam to go. Anyway, yeah, our p and our q is going to be the coefficient of our dx and our dy. So you can see in our problem there, our p is going to be phi of y, and our q is going to be psi of x. So let's go ahead and calculate. Well, we don't really have to calculate our partials, do we? We can just write them out. So that's going to give us, by Green's theorem, we will have the double integral over d of psi prime of x minus phi prime of y, and that's all going to be dx dy. Well, there's no real way for that to be 0, right? It's not always 0. You can plug in values for those functions to be 0. For example, if we have when psi is x and phi is 0, then it won't be 0. So this is not 0. If you recall the problem here, we want to find out which of the following is 0, and that is obviously not 0. So like an X there on the iPad. And then we will do the next integral. So let me get to a new page. This one's already kind of full. Hopefully I don't have to make too many new pages here. But yeah, I'll write down this next integral here. So the next one we want to check is the integral of s of phi of xy times y dx plus x dy. So y dx plus x dy. We're going to write that out so we have it in our PQ form that we want for Green's theorem. So that will give us integral over s of, let's see, I'm going to actually pick up the iPad and move it over here. That's probably better, right? Set it, let's see, live adaptation. Will this work? No, I don't know if it's going to work. All right, we'll give it a try. We've got phi of xy times y dx plus phi of xy times x dy. So now we're going to have to actually calculate some partials here. So let's go ahead and do that. So we want to know the partial of q with respect to x, and that reminder that q is the coefficient for the dy thing. So we have that. So that's going to be equal to the derivative with respect to x, or the partial with respect to x of phi of xy x. Well, we're going to use the product rule in that, and what's that? That's going to give us, let's see, it would be x times d over dx of phi of, xy plus phi, wow, that's not a phi. I don't even know what I was going for there. Phi of xy times 1, because the derivative of x is obviously 1. Now we're going to use the chain rule on phi of xy here, which is going to give us x times phi prime of xy, and then taking the derivative of the inside is just going to give us y plus phi of xy again. So that's the derivative of q, and I can't fit in p at the bottom, so I guess we'll go on to the next page. Maybe I should write it a little smaller. Were you guys able to see all that? Good. I guess the dx got cut off, but I'll try to pay more attention to that as I go. So now we're going to take the derivative of p. Well, I guess I'll write p for shorthand. P with respect to y, which is going to be equal to the derivative, or the partial with respect to y of, let's see, what was our p? Oh, it's just phi of xy y. So we have phi of xy times y. Wasn't there something else? No, that's it. I don't know. I feel like I'm forgetting something. I'm not. So we got the product rule once again. Have y times d over dy of phi of xy. That's going to be plus phi of xy times 1. And using the chain rule once again, we're going to have y times phi prime of xy times x, because taking the derivative of the inside, then plus phi of xy. Now, if you remember from our original formula, we're going to be subtracting these two partials, so if you can tell already, they are in fact going to cancel, and that will give us 0, but let me write it out so that you can see that. So we'll have this double integral over d of, let's see, we have this right here, and this right here, and the q comes first. So we'll have phi prime of xy times xy plus phi of xy, and that's going to be minus this thing up here, minus, see if we can fit it in here, y, well, let's rewrite it like we did the other one, phi prime of xy, xy plus phi of xy, got it in there, sort of. And then dx dy, well, that's obviously always going to be equal to 0. So we have that 2 is a solution. 2 is equal to 0. So 2 is 0. All right. Now, if we will go back to our answer choices here, we have disproved 1 and proved 2. Let me get my head out of the way here. We have disproved 1 and we have proved 2. So the only answer choice that we can choose with those two being the case is going to be C, 2 only, as D has 1 and 2, and so does E, and we've already disproved 1. So that means for number 12 here, the answer choice is going to be C. So let's see. C for that one. And that finishes this problem off. Alrighty, so for the next one, this one is actually a rather simple integral. We're going to be evaluating the integral from 0 to pi of sine cubed of x. When I saw this problem, I was like 99% sure I've already done it. So I don't know if I just did this in like a calculus 2 class or something like that, but it's pretty cool. It's a pretty cool problem. So let's see. Let me get the window capture off of here so you can see what I'm about to write. I will find something to do with my head. All right, oops. We've got number 13, which is the integral from 0 to pi of sine cubed of x dx. Alrighty. So first we're going to use the fact. We're going to make a substitution. It's like fact, which is that sine squared of x is equal to 1 minus cosine squared of x. That is a super well-known fact. I hope you know that if you're watching the stream. So let's go ahead and plug that in. 0 to pi, and we will have sine of x times 1 minus cosine squared of x dx. Now we're going to multiply that sine through and split it up into two integrals, so I'm going to kind of do those two steps at the same time, but it's not too difficult. Then we're going to have the did I say derivative earlier? The integral from 0 to pi of sine x dx minus the integral from 0 to pi of sine x cosine squared x. There's a negative in there, right? No, that's the minus there, yeah. Dx. Alrighty, so this one is obviously really easy to do. This is going to give us negative cosine of x from 0 to pi. So we can see that's going to be negative cosine of pi minus negative cosine of 0. That's going to be a plus there. And cosine of pi is negative 1, so that's negative 1, which is positive 1. And this is the cosine of 0 is 1, so we're going to have 1 plus 1, which is 2. So that gets rid of that integral for us here. Now, over here, we're going to need to make a u substitution. So we're going to let u equal cosine of x. That will mean that du is equal to negative sine of x dx. Well, when we plug that into our integral, we are going to have the following. We'll have the negative, the integral from 0 to pi of, let's see, that'll give us u squared, and then we'll have a negative du because, you know, the sign there is positive, but that negative will let us cancel out this negative. And then we can, I guess the bounds of integration aren't 0 to pi. They are. I will just leave them off because we're going to substitute at the end, but you could, you know, if you're going to do this properly, you would change the bounds of integration when you change your variable. That's just standard practice. But I'm just going to leave it off because we're going to substitute our values back in a second. So that's going to give us plus the u cubed over 3, which is equal to cosine cubed over 3. So that'll give us cosine cubed of x over 3 from 0 to pi, if I'm not mistaken. And when we evaluate that, we will get negative 2/3. I'm going to just say that out loud because it's I don't really want to get another page just for that. So that is going to go to negative 2/3, and that will give us our final answer of 4 over 3. All right, any questions on that one? I haven't been taking questions. I probably should have. Can we just do u sub here? Yes, we can do u sub, yes. Guess that comment was from a while ago, but yeah. So that finishes that one off. I'm kind of rolling through these, but if you guys have any questions, shout it out, and I will check the chat after every problem at the very least. But, you know, it's hard to do math and check chat, especially because when I'm doing math, I'm usually not looking at chat. I'm looking at other math stuff. Alrighty. Well, that finished that one off. Hey, look, I didn't write underneath my face. I'm learning. Alrighty, so let me show you guys number 14, or the chat instead. Here we go. So this says, how many abelian groups are there of order 360 up to isomorphism? So this is actually pretty straightforward to do if you understand the fundamental theory of abelian groups. So to do this, we're going to want to first like factor 360. So, oh, let me get rid of this so you can see what I'm doing now. Alrighty. There we go. We're going to want to factor 360, and that is going to be equal to 2 cubed times 3 squared times 5. Now we're going to want to split this up into a bunch of different combinations to see how many there are for us to see how many groups there are. So we'll start off with the first one. Oh, that's an eraser. So that'll be the whole thing written out. So we'll have C2 cross C2, cross C2, cross C3, cross C3, cross C5. So that's 1. Then we'll have C2 cross C2 cross C2 cross C9 cross C5. That's another one. Then we'll have C2 cross C4 cross C3 cross C3 cross C5. That's another one. And then we'll have, did I miss one? That's 3. We're going on to 4. Nope. We'll have C2 cross C4 cross, that's, man, my handwriting gets worse as I go, doesn't it? Cross C4, cross C9, cross C5, and then I believe we've got 2 more. Then we'll have C8 cross C3, cross C3, cross C5, and then we'll have C8 cross C9 cross C5, and you can calculate what each of those are, but that's not what the question's asking. It's just asking how many of them there are. So that is going to be 6, which is, I believe, yes, answer choice B there. Alrighty, any questions? I'm gonna get some water, actually. I'm already suffering. Let's see. Got a big old gallon of water. Do you drink your water by the gallon? I do. It's pretty cheap. Michael would not approve of me using a gallon of water, but my friends bought me a bunch of stuff for my housewarming when I first moved in here, and this is a byproduct of that. It does not approve of plastic waste. Combinatorial solution. As in, like, they should have asked for a combinatorial solution? It's just asking how many there are. Yeah. Yeah, this problem is pretty straightforward. It's not too difficult. I was kind of disappointed because I was pretty stressed last stream because some of the problems were really hard and I didn't feel like I prepared enough to do some of them. And then I looked at these and I'm like, oh, it's not too bad. There actually is, it might be the next one actually. There's a probability problem on here. I just couldn't figure out how to do it all. Like, I didn't even know how to start it. Well, I mean, I was able to estimate what the answer was, but I wasn't able to properly come to a numerical solution, if that makes any sense. Okay, yeah. But yeah, so let me show you that actually. I don't think I'm going to do it here, but if we get more people in the stream, maybe I can ask for help. Ask for help. Help the streamer. Help the streamer do math. Let's see, let me bring it up. It is this one. Here we go. So we've got, gonna put me in this little gap right here. Let's see. There we go. Yeah, so this problem is the one that I was not able to figure out a solution to. By taking the probability of each kind of situation, I was able to estimate that the answer was between 0 and 8, but I wasn't able to prove it or come up with any kind of mathematical basis for it, other than just kind of bounding what I expected by eliminating outliers and stuff. But like I said, I'm going to leave this one on the table, and we can dive into it maybe later if there's more people in chat that can help me out, or maybe I'll just go about and show what I did to estimate, and then you guys can tell me if I messed anything up or something like that. Yeah, I know. The last one was crazy. There was especially that one integral was crazy hard. Oh, you're seeing chat. I'm failing. Yeah, it was crazy hard. But yeah, so far this one's been a cakewalk. But this probability problem, like I said, I was able to estimate the answer, but I wasn't able to I don't know, I haven't taken a class on probability, so my familiarity with kind of these, I guess this is kind of a strange probability problem, is pretty low, so I wasn't super confident in to begin with, but I can show you what I did later. But anyway, let's move on to number 16. So this is kind of a standard separable differential equation. We have a tank that has 150 liters of salt water with 0.7 kilograms of salt per liter, and salt water containing 0.5 kilograms of salt water is added at a rate of 7 liters per minute. The tank is kept at a constant volume by draining water at the same rate, assuming instantaneous mixing. At what time is there 90 kilograms of salt in the tank? So a few things to notice right away is that the salinity level will be going down because we're adding salt at a concentration of 5 kilograms per liter, and we started with 7 kilograms per liter. But this is pretty standard separable differential equation. So let me get started on that. Let me bring chat again too. Yeah, I'll go into what I did for the probability problem. I'll just do it after. See if we can get any math whizzes in the chat to coach me through it. I thought that might be fun. Alrighty, so let me get out my notes for this one, because this is kind of a long problem. I wouldn't say it's difficult, but the likelihood of me like misreading my notes is pretty high, because it's pretty long. I would say this isn't like a great problem for stream, just because it's longer than it is entertaining. But anyway, so let me actually write out the facts here. So we've got, let's see, starting. We have 150 liters of water with 0.7 kilograms of salt per liter. And the rates we're given are, let me see, we're adding adding water with 0.5 kilograms per liter. Oops. And we are sorry, I need to add that. Adding water with 0.5 kilograms per liter at a rate of 7 liters, I believe it's per minute, right? Yeah, per minute. And it's exiting at the same rate. So we're like, presumably we're mixing it together, and it's, you know, perfectly mixed as it goes in, and it's exiting at the same speed. I don't know, we're mathematicians. When I was in engineering, they would be like, well, the salt, what happens to the salt? You have to mix the salt. You know, you can't just, you know, they're more, oh, I'm blocking it again. I'll learn. I'll learn eventually. Yeah, so it's exiting at the same speed. So we're going to set up, like I said, we're going to set up a separable differential equation. Even though I have not taken differential equations, I have done many differential equations. So we have ds over dt is equal to, it's rate in minus rate out. I was going to write it fancy in my notes, but I already decided against that. All right, so our rate in is going to be the kind of what we wrote up there. We're going to have 0.5 kilograms per liter times 7 liters per minute. And that's going to be minus, we're going to have S kilograms over 150 liters, and it's going to be exiting at the same rate per minute. Alrighty, so that's going to give us, I have 3.5 kilograms per minute in minus 7s kilograms over 100, well, hold on, let me keep it separated like I had. 7s over 150 kilograms per minute over here. And that is equal to ds dt. Oh, hold on, got a big comment. Yeah, thanks for the comment. That's a good suggestion. I think Michael has in the description of all of his videos a problem suggestion link. It's like a Google form, I think. So if you have any problems you want to see us do, he does look at those very frequently. In fact, I think he uses them as like a primary motivation for what he picks to do. Be sure to suggest any problems that you have in there, and maybe he'll pick it. But yeah, thanks for the comment. Thanks for stopping by. So, yes. I got lost for a second. All right, so yeah, let's combine these into kind of one fraction by multiplying this first term here by like 150 over 150. So that's going to give us, because we want to separate our s and our t, it's going to give us 525, because that's 3.5 times 150, minus 7s over 150. And then this will set us up for our integration here, which is actually a really good place to like stop this page. It's a good place to stop. We'll have 1 over 525 minus 7s ds is equal to 1 over 150 dt, and we're going to integrate both sides. So I will do that on the next page. Blocking again. Oh no, this is so sad. No. All right. Anyway, yeah, let me give you a second to read that. Alrighty. So we will start off by integrating those there. So we will have on the left-hand side the integral of 1 over 525 minus 7s ds, and that is going to be equal to, on the right-hand side, 1 over 150 dt. Now 150 dt, that is super easy. That's going to be equal to the following, which is going to be 150 t plus some constant. I'm not going to specify like I'm going to use a lot of constants here because when we manipulate the math, we're going to have a bunch of constants that we pull out. But I'm just going to, only one really matters for us to get our solution. So I'm just going to combine the constants and not keep track of them. But that's generally like poor note-taking problem-solving technique. So make sure that you don't do that. But anyway, so that's that first integral is done immediately. For this second one, we're going to do like a really quick u sub. We're going to let u equal 525 minus 7s, and that means that du is going to be equal to negative 7 ds, and that will give us the integral of 1 over u, and then there's going to be 1/7 out here, du, and that's obviously going to be natural log, so I will go ahead and take care of that. That's going to be equal to negative 1 over 7 of the natural log of the absolute value of 525 minus 7s, and I'll bring that other side down here. We'll have 1 over 150 t plus c. This is getting kind of sloppy. I'm doing my best. Left side of the equation has no units, right side is in t. Left side has s. Yes, so let's see. We are going to get rid of that 7 there. So let me just, we're going to start kind of rewriting the math so that we can get it in a nice place to work with. So we're going to get rid of that 7. That's going to give us the natural log of the absolute value of 525 minus 7s is equal to, let's see, we multiplied by 7, so negative 7t over 150 plus c. Let's see, where do we go from here? We're going to exponentiate to get rid of that natural log. So we will have absolute value of 525 minus 7s is equal to, let's set this whole thing up here. Oops, got an eraser. Let's set this whole thing equal to, let's just call it like b or something, just so we don't have to write that out every time. So we're going to have, which is equal to e to the, let's see, to the B, right? Yes. Well, actually, let's not do that just yet, because we're gonna do something with the exponent. So e to the negative 7t over 150. Yeah, I knew I was forgetting something. Plus c. And we're gonna pull that constant down. So we're gonna have c times e to the negative 1/7. Wow, I'm negative 7 over 150. And I guess we'll put the t up here, t. And then we are going to, let's see. I am missing something. Yeah, I know. They let the rate in equal the rate out. It's beautiful, isn't it? I don't have to account for it. Yeah, my notes just had me dropping the... Yeah, we're going to plug in 90 for t, but we have to find our constant before we can evaluate. So we're almost there. We're solving for our constant right now. That's actually a good progress check. Anyway, so we're going to have 525 minus 7s is equal to c e to the negative 7t over 150. And from here... Yeah, now let's set this thing equal to let's call this b. So we're gonna try to isolate s here. So we're gonna get negative 7s is equal to negative 525 plus c e to the b. We'll divide by negative 7. That will give us s is equal to 525 minus c e to the b over 7, right? And from here we are given for our... Oh, I didn't realize the iPad is cut off. Can you see that now? Yes? I think that's good. Yeah, you wrap the plus or minus in with a C. Yeah, thank you. So our initial condition, let me show you real quick on the thing. We had an initial condition for the salt, so that we know here, we know that s at t equals 0 is equal to 150 times 0.7. So we're going to plug that value into this equation here so that we can solve for our constant, and then we can do the same thing to solve for when t is equal to, or we can solve for t when we have 90 kilograms of salt in the tank. So let me swap back to the iPad here. Yeah, so that's going to be, we will have 150 times 0.7, what is that? 90? That's 90, right? I think. Yeah? Yes? Someone verify? So that's going to be, I'll just write it out. So we'll have that 150 times 0.7. I should probably do 0.7. We're kind of running out of room here. 0.7 is equal to 525, and that's going to be minus just c over 7. And that is because when you plug in a 0 for t, the exponent of e goes to 0, and then e to the 0th power is 1, so it's just minus c. And then I won't bother you with the arithmetic here. We will have that c is equal to negative 210, which is expected as... it should be lower because we're putting in salt at a lower level than we had to start with. So that gives us our value for c. And now, let's see if I can find where I did the last part of this problem. Now, somewhere, maybe, this is really an obnoxious problem. We will finish this thing off. So we will have that. What do we want here? We're trying to solve for t when s is equal to 90, correct? And we have our value for c now. So we have 90 is equal to 525 minus, and then we have, it's minus 210. So we'll do plus 210, right? I didn't mess that up, did I? No. Plus 210 times e to the negative 7 over 150t, and that is all over 7, right? So far, so good. 105. What did I miss? Did I miss something? Is it not 90? I feel like it's not 90. I don't think my notes think it's 90 either. Let me see. No, it is, right? Yeah, because you multiply by 7, you get 630. Is equal to 525 plus 210 e to the negative 7 over 150t. You subtract 525, and that'll give you, oops, eraser, 105. Shoutouts to whoever told me how to get rid of that eraser feature, and then I just didn't do it and forgot about it until just now when it's bothering me. 105 is equal to 210 e to the negative 7 over 150t. So I'm going to rearrange this so we have, I'm going to rearrange this so we can cancel the negative in our e exponent. So we will have on this side e, because if you divide it over, it'll be a negative exponent, so it'll make it a positive. We'll have e to the 7 over 150t. I'm not really writing this right. T should be up here. Is equal to 2. And then we are going to undo our exponentiation, and we'll get that 7t over 150 is equal to the natural log of 2. And then that will mean that t is equal to 150 over 7 times the natural log of 2. And hopefully that is an answer choice. Never sure. Although this one I'm fairly confident on. Yeah, it is A. It is A. A. And I avoided blocking the camera. We're making progress. Okay, so that is number 16. Now, are there any questions? Does anybody want to point out my horrific mathematical flaws, if I had any? I don't know. I'm going to go ahead and write out number 17 while I wait for those questions. So we want to know for which theta is 2, I think I can fit this in here. Nah, I'll play it safe. 2 plus 3i sine theta over 1 minus 2i sine theta, purely imaginary. Purely imaginary. And that fits, so that I'll use that question mark as my guide for what's too far to the right. All right, so for this problem, what you want to do is you want to get your real part in terms of sine theta, so you can kind of see how it is being affected by the values for theta in a pretty clear and easy to see way. And I'm going to do that in the following way. I'm going to, let's see, I'm going to multiply this expression by a type of 1 that's going to help us out here. So we have, this is our expression here. We're going to multiply it by 1 plus 2i sine theta over 1 plus 2i sine theta. And that is going to give us the following on the top. We'll have, let's see, we'll have 2 plus 4i sine theta plus 3i sine theta minus 6 sine squared theta. And that is, of course, going to be over 1 plus 4 sine squared theta. And let's go ahead and split that top part up into real and imaginary. So we'll have 2 minus 6 sine squared theta. And then that's going to be plus I, and I think, yeah, it's just the 7i sine theta. I times 7i sine theta over 1 plus 4 sine squared theta. And we want to find an answer choice that will make this real part on the left go away completely. So let's look at our answer choices. It should be very obvious now that we have it in this form. And it is, in order to undo that. Wait, did I write that wrong? No, I didn't. Yeah, in order to get rid of the 2, we're going to have to plug in something for sine that will give us a -2. But since there's a 6 in the coefficient, we're going to need to use the number 3. And we can see that if we plug in this inverse sine of 1 over root 3, we will get that. I'm not going to go through it, but it's kind of a trivial calculation. But that is our answer there. It's going to be C. So we'll have C is our answer choice there. If you plug in the inverse sine of 1 over root 3, you can figure that out in like seconds. And that finishes this problem off. Let me see. Do we have any questions? How's everybody doing? Oh. 7 sine theta. Did I write something wrong? Oh, I wrote an I on the inside. Yeah, thank you. Yeah, no. That's definitely just 7 sine theta. Thank you. Good catch, chat. Alrighty. I think we are good to move on to number 18. There's only 22. We are making really good time. Last time I was suffering, but we are making good time. So let's move on to number 18. Let me get what that is, because I don't remember. Is it? Some of these are just logic. Like I don't even need to, yeah, and this is one of them. Here, I don't need to do any math for this one. So let me get the window open here. Put the iPad down. Relax a little bit. I have so many electronics in front of me, it's a little bit smothering. Let's see. We have... There we go. All right, let me move my head. So we want to know which of these following 2 conditions imply that the sets A and B have the same cardinality. Now, if you look at these first 2, it's really a matter of left and right inverse. So for the first one, we have f is a function from a to b, and g is a function b to a, such that g composed with f is the identity of a. Now that, in order to prove that these functions have the same cardinality, you need to prove that there is a function between them that is both surjective and injective. But here we have 2 functions. One is surjective and one is injective. One is a left inverse and one is a right inverse, respectively. So that is not enough to prove cardinality because it's not on the same function. Now, for number 2 here, we actually have enough to work with. So we have that A is a subset of B, so right away that tells us that A's cardinality is less than or equal to B's cardinality. That gives us one direction for showing that they're equal. And then our functions here give us that f composed with g is gives us that we have a surjective function between them, which says that A is greater than or equal to A's cardinality is greater than or equal to B because there's a surjective function that way. And that gives us both sides of the inequality, which lets us know that the cardinality of A and B are equal in that case. And for number 3, that is just true. I have a cute little proof for it I can write out for you on the iPad, but that is a true statement. It's like fairly well known, I think. Do you guys know that? If you saw that, would you be like, oh yeah, that's definitely true? I can say I didn't. But anyway, the answer for this is E. I'll write out the little cute little proof I found for that statement there. So let me get rid of this window capture so you can see me again. All right, cool. No, yeah. So we have cardinality of A, and that is going to be equal to cardinality of A intersect B. Oops, there we go. Plus the cardinality of A. Is there a difference? Cardinality is not the right word. It's like the size. I guess size is better to say than cardinality here. Anyway, that's equal to that sum there. And I could write it further to the left, but let me move my camera back. And then that is going to be equal to B intersect A plus B intersect A compose, which is equal to B, cardinality of B. Yeah, that's just a quick little line. Yeah, for the second one, A is a subset of B. This is for the third one. Here, let me show you the third one again. This is for 3. I can link, I guess I forgot to ask, but I'm following along with a University of Chicago GRE preparation thing that we found online. And I'm on week 1. This is problem number 18. So you can actually do these problems on your own. If you want to, let me just shoot the link in the description for you guys so you can kind of look at it directly on your own browser or whatever if you would like to follow along. So let me grab that for you. Here is the URL. There you go. I would put it in like the comment after the stream is over for people who visit, but from what I've seen for the first stream, that's not that many people. A lot of people watch it. Anyway, yeah, so it's just 2 and 3, which I believe is answer choice. Which one is that? E. 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 Is it worth leaving that? I might just erase and reuse this paper. Yeah, I think I'm going to do that. Goodbye. Number 18. You did well. Alrighty, so let's get number 19. Number 19 is a complex integral. Who likes complex integration? Who likes complex analysis? Let me know. It's cool. Here, let me show you the problem. For the record, when I'm looking at this sheet, I cannot see chat, so if you're saying stuff and I miss it, I'm sorry. Anyway, so let C be the circle of radius 2 about the origin in the complex plane traversed counterclockwise. We want to compute that integral there. We're going to do this using residue theorem, I believe it's called, residue theorem. I just took complex analysis, but the way Randolph has it, it is split up into sessions, so we have quarters. So I took complex analysis in a quarter, but I also did an independent study. So instead of doing both at the same time, I did the independent study for the first half of a quarter and complex analysis in the second half of the quarter. So I really crammed this information. But it was fun. It was very fun. I learned a lot of math. I believe in going hard in the paint when you're trying to do something, and I really did. It is very difficult. I wouldn't even recommend attempting to try to learn an entire semester's worth of complex analysis in a fourth of the time, but I did my best. I did do my best. Anyway, let me get this iPad available to you. So we have this integral over here of C, and that is 1 over z squared plus 1 dz. For those of you who are interested, let's see, test my knowledge. I believe there is a video on the Math Major channel for complex analysis. I think it's video number 22 that goes over residues. It's either 21 or 22. That goes over residue theorem and how you can use it for integrals. So if you want to understand this process, just watch that video real quick. It's about a half hour, but I mean it's like a course lecture, so it's not going to be short-winded. Anyway, that is going to be equal to, actually first, let's go ahead and factor this because we want to see where these singularities are. So that's going to be 1 over z plus I and times z minus I. So that kind of paints the picture for where our singularities are going to be. It's going to be when z is equal to I and when z is equal to negative I. And because of that, we're going to be able to solve this using residues. So we're going to get, that's going to be equal to 2 pi I times our function, which is 1 over z squared plus 1, evaluated at z equals I, and, right? Yes. I don't know if I should have put that comma there. And then same function, z squared plus 1 at z equals negative I. And it's, oh, I need to write residue. That's not even mathematically correct at all. Yeah, it's the residue at these. I don't know, residue. Poorly drawn arrow. Residue. At, wow. At I and negative I. And so that's going to be equal to 2 pi I times the limit as z goes to I, this is for the first one, of 1 over z plus I. Also, these are supposed to be added. It's the sum of all residues. Yeah, that middle line is just poorly written. I'm sorry. It's good that you can't see it because I forgot my face is in the way. That's just a poorly written line there. Anyway, the integral is equal to the sum of the residues, and in this case, the residues are going to be evaluated at I and negative I. That's the takeaway here. So this is the limit as z goes to I of 1 over z plus I, and that's going to be plus the limit of as z goes to negative I of 1 over z minus I. And we can very easily see that that is going to give us 0 when we plug those in, but I'll write it out just one more. Going further, we're going to get 2 pi I times 1 over 2i plus 1 over negative 2i, which gives us 0, and that is answer choice B. Yes, B. Oops. B. There we go. So that is number 19. Let me check out chat. It's been a while. It's been a minute. It has been a minute since I checked chat. Have we got any more viewers? Are we doing better? Oh, we are doing better. We got 13. Well, we had 13. Please draw a picture for when A is a subset of B. Not even sure what I would draw for that. Yeah, I mean, it would just be like functions, like to show surjectivity and stuff. I'm using fairly well-known analysis stuff. So, I mean, what I was just stating is like this fact, this fact, this fact. But to go into the details of how it like mechanically works would be a little bit more than I need to do there. Anyway, yeah, number 18. Yeah. I'm just gonna move on to number 20. So let's see, which one is this one? Oh, this one's fun. This one's fun. Here, let me show you guys this one. This one's fun. This has a picture. Okay, so we have this triangle here. I'll put the iPad down for a second. Which has this triangle PRS, and we are given the values RT equals 7, PR equals 8, QS equals 9, and we want to find the closest length to side PS. Do you guys like geometry problems? Excuse me. When I was growing up, I loved geometry. I thought it was really cool. I think it's because I'm like a spatial person, but I liked like picturing shapes in my head and stuff like that. And then when I got to Calculus 3, I learned how terrible that gets in higher level mathematics. No, I think calculus is fun now, but not learning it. I think when you're a math student, it is very intense if you want to get a full knowledge of the course you're on. When I was taking these classes as an engineer, I didn't take them with any like trying to learn it thorough, I guess. And as a mathematician, I kind of sorely regret that. But, you know, you live and learn. It gives me an opportunity to revisit topics and master them, which is not, I mean, I guess it was available to me then if I had taken it more seriously. But I think that usually, even if you do pay a lot of attention, you don't master the material until you go through it a couple times after that. So, anyway, I'm way off topic. Basically, pay attention in class, try hard. That's the moral of that story. But anyway, yeah, this problem is, I wouldn't consider this like subject test worthy, would you? I mean, this is This is really easy. I don't know. You guys see the solution? I'm not meaning to insult your intelligence. But here, I will show you. I'll show you. When I wrote this in my notes, I drew a little triangle to go with it. I think drawing triangles is part of the fun of math. If you can't draw a triangle, it's not even a fun problem, you know. Speaking, I should draw the triangle on my notes just because I said that, right? Here we go. Okay, so we got our triangle here. I was thinking we were going to have to do some like hard manipulation. Forgive how terrible this triangle is about to be, by the way. That's part of the fun of drawing the triangles. Oh, I can use the straight line tool. Hold on. Now we're doing this over again. I forgot. We're going to go here. Boom, straight line. Straight line. Oh, it's beautiful. It's not flat, but it's beautiful. Oh, look at that. It like shades it in too. Oh, we're in for it. This is, yeah, who knew? I'm going to try to keep this like straight. Oh, wow. That worked out. And then we're going to go from here to here. Oh, it's so good. Look at this. I'm sorry I'm excited by something this trivial, but it's fun, right? Anyway, so this is a right angle, and this is a right angle. I wish I could draw stuff in my physical notes that's this pretty, like that's just this good. So this up here is going to be R, this is going to be S, this is T, this is P, and this is Q here. So we are given that RT is equal to 7, PR is equal to 8, and QS is equal to 9. And we're going to solve this by writing the area of this triangle different ways and using our values to our advantage here. So the first way we can write the area of this triangle is going to be 1/2 times, I guess I'll write the side length so you can kind of track what I'm talking about here. PS is what we're trying to solve, by the way. We want to know, I guess like side PS. So times PS times RT. And that is equal to, we can write the area this way, is equal to 1/2 times PR times QS, and you'll notice that these are using all of the values that we have, that we were given. So these 1/2s are going to cancel out. That's going to give us PS times 7 is equal to PR, which is 8, times QS, which is 9, and that's going to be equal to, PS is equal to 72 over 7. And if you plug that into a calculator, that is going to be 10.29, which is D. That's what that is. All right. Cool. No, my fancy triangle really made that for me. I'm going to be honest. That made it fun. Do you have comments about triangles? Geometry is great. I love geometry. You guys are still talking about problem 18. Yeah. Sorry about that. I probably could have explained that better. Or I should have prepared a better explanation, let me put it that way. That way it doesn't sound like I'm just neglecting you now. All right, so let's go on to 21. Got my fancy triangle. I think 21 is not a work problem. Oh no, this one's gonna be fun. Okay, I hope you like logic tables because I did not prepare this one, and I think it is all logic tables. So let me show you this. There we go. Okay, so we have these statements here. So we have A implies B. That statement implies C. We have that A implies the statement B implies C. We have A and B implies C. We have B implies A implies C, and B implies A implies C. I hope my enunciation, or how do you say that? Hope how I said that made that make more sense than it looks. So I when I was going through this, I was like, oh, you just do this with logic tables and see which ones have the same output for, you know, the different inputs. And then I realized that that would be really fun to just figure out on stream because it's probably going to be a nightmare to try out. So here we go. We want to know how many of the statements there are logically distinct. I don't usually like to cheat on these problems, but at the bottom there is a hint that says that the middle three are in fact the same. So maybe I will just work out a logic table for like 1, 2, and 5 and see if, you know, 1 is also with 2, 3, and 4, or if 1 and 5 are distinct, and, you know, that, because I think if I made 5 logic tables, it might take a while, but maybe not. So let me figure out, how could we streamline this? I guess we can make a table for A, B, and C, and that would stay the same, and then have like a table in the middle that's like the specifics and then the output on the right. Something like that. Let's go ahead and give that a shot. Let me check the chat real quick before we move on. See how you guys are. Geometry is great. All right, I'm caught up. I'm caught up on chat. Okay. So let's see how we want to do this. Yes. So we could do, we'd have a, let's draw this like all the way over here. Set up our table here. B, C. Let's set up all our values here. We got 1, 2, 3, 4. This is how you set up a three-way truth table, in case you were wondering. Let's see if I remember. I took this class a very long time ago. We went over this in Intro to Proofs, I believe. This F is very sad. That's a sad attempt at an F. I got an F on that F. All right, so this first one, we have that A implies B implies C. So I guess we'll make a, hold on, let me get this all the way over. Let's put this up in the middle here. Like have this going here. All right, and then so for this first one, we'll have in the middle that first part, which is A implies B. And then this will be our output, which is the whole statement. A implies B implies C. Is this overkill? Chat, tell me if this is overkill. I'm not trying to overkill it. Intro to proofs. Can we use A implies B if and only if not A and B? Yeah, I think this is fine. Anyway, if this is taking forever, then we just won't do it. But I thought it would be fun, you know. All right. So if A and B are both true, then A implies B is true. Wait, I wrote that twice. Oh, that's because it's for C. Yeah. So that's true, true, and then if A is true and B is false, then A implies B is false. So that's false and false. And then if A is false and B is true, A implies B is true, true, true. And then if they're both false, obviously it is true. I guess that's not obvious when you say it like that. So by the same logic here, if A implies B is true, then C is true, right? That's how we're interpreting this. I think that's how it goes. If A implies B, yeah, so it's true, true. Is that not just the same? I guess for this example, the far right-hand side is the same as the left-hand side, right? I mean the middle side, right? Yeah, I think so. False. Oh, no, because this is for values of C. I can include C in here, right? My brain is not. The second one is false. What do you mean? Elaborate. Did I mess this up? Oh, this one's false right here. Is that what you're saying? On the final column, the second one is false. Yeah, because C is false. Yeah. That's what I was thinking. So this is true, false, and if that's false, this is false, right? No, this is, hold on, third, yeah, this is true. True, and then this is false. Wait, if they're both false, it's true, right? Yeah, this is true, actually. Now they're both true, so this is true. C is false, so this is false. I should have done rows. Oh no. I should have done rows. They're going to be all over the place. But we'll just be looking for this patternation. So I'll like save that, I guess, at the top or maybe at the bottom for ease. The patternation from the first one, and then the second one, and like I said, the hint says 2, 3, and 4 are the same, so we'll just like take that as fact, and then we'll check the fifth one and see if 1 and 5 are the same or not. Anyway, so that's false. This is true, and this is false, right? Somebody check me on that. Think that's right? Think that's right before I erase it, before it dies forever? That would be pretty sad. I'll just go to another piece of paper, and then if it's not, let's see. We've got true, false, true, 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 false, true, false, true, false, true, 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 false, true, false. Did I remember that? Oh, I'm good. That's for number 1. There we go. The last one is true. It is? I don't think it is. Because because C is false. See, that's why I should have made rows. Yeah. No, it's supposed to be false. C is false. A implies B is true. So C is just false. This A implies B implies C is false, right? Yeah, okay. I blame the rows. You're not dumb. I blame the rows. So I'm going to erase this, keep the A, B, and C the same, and change these here, and then add rows right now before I forget. Oh no, I've made holes in my. Oh no. Oh dear. Can we fix it? Close enough. All right. So what is the next one? It is that A implies B implies C. So the middle should be B implies C, and the far right should be the whole statement. Yeah. So we'll have B implies C, and the far right will be A implies B implies C. All right, let's get some rows in here. Oh no! See, this is why you need rows. It's acting up. So this is a true. This is a false. There we go. I have a feeling that's not going to go well. Yeah. Let's just leave that. Let me just try to line these up a little better. True. False, true, false. See if that'll do it. No, not quite. I'm just going to erase the last 3 and rewrite them. Oops. Why isn't it working? There we go. It's being difficult. Yeah, my line drawing is really not at its peak right now, is it? It's could be better. Could be better, I'll say. All right, so that's false, true, and false. And then let's draw the next line. false, false, true. And then this is the last one, so I won't draw a line at the bottom. False, false, false. Okay, so let's get started on this. Got like a little cheat sheet here for truth tables to make my life easier. So if B and C are true, B implies C is true. If B is true and C is false, this is false. If B is false and C is true, this is true. I'm just going to go through these really fast. This is true, true, false, true, true, right? Yes, perhaps. Perhaps. Okay, cool. So for this one, we'll have true. And then this will be false. This will be true, 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 true. Are they really that all true? Is that right? Or did I just butcher that? No confidence in this. Perhaps. Perhaps. Let me think about it. Yeah, if that's true, that's false. That's false. Should be another false case, right? Okay. Yeah, okay, so that's interesting, actually. Well, obviously, that's distinct from 1 to begin with. But we'll have to check and see if it's distinct to 5. So I guess I will wipe this out, and we'll check 5. I guess I'll go ahead and write it, even though it's exceedingly easy to remember. We have true, false, true, 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 true. That's for 2, 3, and that'd be 4. Yeah, look at my Roman numerals going. All right, so now we'll check 5. I don't remember what 5 says. Can I just tap it? Oh yeah, boom. Yeah, I've never used iPad stuff to take notes or anything. It's quite nice, I'll be honest. Till these streams and example videos, I'm still getting used to it. I've gotten into a habit of recording my example videos late at night. I think the most recent one was recorded at about 3:30 in the morning to peel back the curtain a little bit. I was exceedingly tired, and I made a few arithmetic mistakes, but I don't know. The interesting thing about it is my math game was worse because it was like so easy. I took it for granted and made like an arithmetic mistake or two. I think it was just one. I don't remember. But I did the recording part perfectly. Like I did like almost everything in one take, and that usually doesn't happen. B implies A implies C. Is that the last one? Are you asking why I did it at 3 o'clock in the morning? I couldn't tell you. I couldn't tell you. Don't ask me. And then this is implies C, like that, yeah. Yeah, no, I don't know. I mean, I get into a work state, and I tend to, like, check, like, I'll start later at, like, 9 o'clock. I usually work in the really early morning and really late at night, which means I just don't sleep very much. The whole day I go about. But, I mean, I don't know. It's because I'm a night owl, really. So, like, if I get rolling at night, I'll just keep on going. But that's kind of my general work state, is if I get started, I'll just start going. I probably need to get better about starting earlier, I guess. But it's kind of a student mentality. Like, now that I've graduated and stuff, that's not really a good way to do life. So I've been working on it, but, you know, old habits die hard, I guess. I can't expect to just change how my productivity goes all at once. But, all right, so let's get this truth table going. So B implies A, that is true. I guess I got to think about this, like, backwards because the B is in the middle. That's true. That's true. True. False. False. True. True. Right? Like that? true, true, false, false, yeah. True, 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 false, false, true, true. I think that's right. If they're both false, it's true, yeah. Okay. So same thing here. This is true. If this is false, if they're both true, this is true. If that's true and that's false, that's false. If this is false and that's true, that's true. If they're both false, it's true. If they're both true, it's true. And if that's true, it's false. So is that the same as 1? TF. No, it's not. It is not. It's nearly, but it's not. Unless I messed something up. Anybody see a mistake with that table? Are we about to lock in the answer 3, which is hopefully an answer choice? It's going to be like a staple of this series, I can already tell. Hopefully that's an answer choice. Hopefully that's an answer choice. Let's see. Is that an answer choice? It is. It's C. Okay. So that will give us C. Good work, gang. We're on the last problem. Woo! Yeah, this one has flown by compared to the last stream. We're making good time. Alrighty, so this one I definitely need to show the screen for. This is a proof. We have to find the mistake in the proof, and I can give you a little background here. I won't need the iPad for this, so I'm just gonna set it down. Okay, here we go. So we have this attempted proof here. So we have consider the following attempted proof of the statement, excuse me, that if x is a compact subset of R, then a continuous function f from x to R is uniformly continuous. We use, that's just notation about the, I got my face in the way, hold on. We're moving down. I'm gonna like peek from the bottom here so you can see the whole screen. So that's just like an epsilon ball notation point. Anyway, so for this proof, we should be looking for an error based on the fact that the set has to be not just compact, but it has to be connected. And the reason for that is, I guess I will use the iPad. The reason for that is, hold on, let me remember how to work OBS. I've done it. The reason for that is that if you have it not connected, you can have something like this. You can have, like, let's just say we have some interval here with a hole in it. That would be like it's not connected. When you choose your x and your y for your finite subcover, it is possible to choose an x that is on this side and a y that is over here, and then you don't have uniform continuity. So we're looking for where we don't consider, or where we would need to consider connectedness, and that's in the finite subcover step, which is 2. I think that's 2. But it's kind of like there's basically a proof to say that this isn't true because of this issue right here. That is your counter, your disproof of this proof, if that makes any sense. So let me get back to the proof on screen here. Be the window capture here, yeah. So by compactness, there exists a finite subcover. So like that's not true, or that doesn't work rather, because it's not connected. Or we're not assuming connectedness, I should say. If we're not assuming connectedness, we run into an issue with continuity. And it makes sense in the example I showed you there. You can't have continuity if there's a break in your function. So are there any questions about that? That is our last problem. Dang it, I keep showing you the chat. Let's go with here. There we go. Any questions about these questions? I would do the probability one, I really would, but now that we've made such good time, I kind of just want to be done. I can show you, well, let me just like make a mock-up of the thing I did here and give you like an abridged version, right? Just for your own, just to be interesting. So let's see. Let me get this thing I did earlier. Bring it up. So we have, let me explain this problem first because it's not like super clear even what it means on the first read, at least it wasn't to me. So we've got a guy, he flips 10 coins, and then based on the results of those 10 coins, he then flips another coin that's based on this little equation here. So if he flips a maximum of 2h minus t squared coins. So if 2h is 0 or less, he doesn't flip any coins. Or yeah, if 2h minus t squared is 0 or less, he doesn't flip any coins. Is basically what that means. So, but what I found was, and I made a probability table on the likelihood of every coin combination happening, right? So let me show you my iPad again. Yeah, so we've got like the heads on this side, 0 to 10 possible. This is for the first set of coin flips, right? So we've got one. Here, I should do my rows. One. I don't know. This is already. I'm not gonna even bother making it really nice. I feel like you could just use the undo arrow, but we've committed to our course of action. 1, 2, 3, 4, 5, 6. Rare footage of me counting past 5. 8, 9, 10. And then the probability of the outcome, I put in another column here. So it's the probability of outcome. That's not prob. I failed. Did anyone else write P instead of B when they were in elementary school and never grow out of that? Because I still do it as an adult, and I'm not quite sure why. It's not like I don't know the difference. I don't have like any disability. I just like subconsciously do it. Probability. I'm not even going to write of outcome. That's the prob. It's the prob. So this is 1 over 2 to the 10. This is 10 over 2 to the 10. I think I'm going to run out of room. I wrote these too condensed. And 10 choose 2 over 2 to the 10. And it goes up to 5. So like dot, dot, dot for 5. 10 choose 5 times, not times, over 2 to the 10. And then it goes back down. It mirrors the above. And then because the chance of flipping 10 is the same as flipping 0, so then we'll have 1 over 2 to the 10. So what I found was, because I had to estimate this, because I wasn't sure how to like combine it and to get some kind of expected value. But what I found was, first thing to note is that if t is greater than or equal to 4, there's no second flip. In the first flip. Which means that we're going to be dealing with, in order to consider the second flip, we're going to be dealing with, so for second flip, we're dealing with t less than 4, or basically like 3, 2, 1, or 0. And what I found was that once you even go to a t equals 3 situation, you're in an extremely like minority situation. So if I remember correctly, this is just off the top of my head, don't quote me on this, the chances of this is like 11%, and then it goes 4%, then it's like 0.9%, and then this is just like infinitesimally small. It's 1 over 20. This is 1 over 1024 percent of a chance. So realistically, the second flip doesn't strongly influence the probability, or like the total number of heads, right? So like your expected probability for 10 coins is going to be 5, obviously. But because we're dealing with the outlier cases, it would only pull up. This is an estimation, right? I'm not like I think I got a number when I did some multiplication and stuff, but I don't know if it's right or not. But basically, like, it's only going to pull up 5, like, very small amount, because the only cases that we're talking about where we would get a number of heads that's like way higher than 5 is going to be really, really, really unlikely, which means our expected value is not going to be that high. So my answer choice for this was A, between 0 and 8, because I cannot really see in the math how it would be any higher than 8. That's already like really, really high. Because, I mean, you could be like, oh, well, if you flip 10 heads, well, then you have a chance to flip 20 more heads. And it's like, yeah, but if you flip 30 coins and they're all heads, you're 1 over 2 to the 30th odds. It's just not going to happen. It's like so unlikely that it doesn't influence your expected value. So that's how I estimated this problem. I'm pretty sure that's the right answer, but I am open to suggestions. Yeah, I agree. You could split it up and do add the expected values together. I think that's the way that you do it. I'm just not comfortable enough with expected value calculation to do that, and because we have the luxury of multiple choice, I don't think that it's necessary. But that's how I kind of went about it when I explored, because I think when you do problems that you're not sure how to approach, doing a little exploration like this is probably pretty good. You look at the things you do know and see how you can apply them, and maybe you can see a route to do it. Yeah. Yes, yeah, I agree. The expected value for the first part is 5, and the expected value for the other flips is depending on how many flips you do. And I also made a table for like each value of t and how many coin flips there would be and the expected value for those. I did do that. Maybe I was just missing adding them up. Like maybe that's all I was missing. But yeah, I think it's 0 to 8 because I don't see how the second flip would statistically influence the expected value of the first one enough to matter. I don't see it happening. Yeah, that was the problem we skipped. So yeah, I'm locking in A. If someone disproves me, I will, when the stream ends, I'm going to have it, live. I don't know how to like make it a video or whatever. I might try to do that after this. But it's available. It's not even unlisted. I think it may be on a different section of YouTube. It appeared in my subscription feed, but it's like when I go to videos on the channel, I don't see it, so I don't know how that works. But maybe I should make a playlist for live streams. That seems like a good idea, right? But anyway, that's this first week for the University of Chicago GRE Prep. The next stream will be on Monday. Hopefully I'll be able to have it earlier because it seems like our viewership suffered. I am aware that most of the viewers are not available this late, but I have, real life stuff, so I can always stream. I'm going to try to get on a schedule though, so maybe like as early as 11 EST to look out for it on Monday. I'll see if I can make that work. If you guys, for those of you who may not know, Michael is doing a stream on the main channel this Sunday at 11 a.m. EST, and that is going to be as part a like all you need to know going into your classes for like a semester kickoff, I guess, to summarize what I was about to say. A semester kickoff to help you like prepare for your classes that you may be going into, your math classes, and also to raise money for the math department budget for the college so he can do some cool stuff. I'm not going to quote him on anything that he was planning on doing, but I think he has some good stuff in the works, and that would translate into content on the main channel that could be really, really cool. So make sure if you are free on Sunday morning to check that out. And thanks for coming out to the stream, guys. I'm going to go ahead and end the stream now. If you have any comments or if you have any mistakes you picked out that I made, feel free to leave them in the comments. Like I said, this is a study and a preparation stream. I'm not by no means like an expert on this. I am just doing my best to prepare for the graduate exam. And I guess I'll see you guys later. So thanks for coming out.